Welcome to this tutorial about AI, and today we're talking about moving between platforms. It is more commonly known as using nav links. So let's jump into it and see how it works. So this little demonstration is essentially what we will be creating today. We have this AI which follows us around with intervals of waiting, and we're essentially just going to jump up on this platform and have the AI follow us here using nav links. So here we are inside of Unreal Engine 5. This is Early Access 2. This will be working the same, although looking slightly different in Unreal Engine 4. So what we have set up here before the tutorial is essentially just a AI character that will walk towards the player, and then he will wait a few seconds, and then he will walk towards the player again. And we have set up that basic functionality just so that we can see how to demonstrate the functionality of the nav links essentially. So what is a nav link? Well, a nav link is, if you press P and you get the nav mesh available to your map, is essentially a way for you to connect between gaps in your navigational mesh. So for example, this mesh over here ends and is not connected with this ground over here, but this could be a place where we could put a nav link and have it traverse between these two areas. Similarly, if we wanted to have a nav link over here to this platform, we could have one going between these two platforms, so it could jump there, for example. So essentially you have a way to bridge between gaps in a nav link. And the use case for this could be many different things, but essentially many games you don't want to have a monster just walking, or a character, or some kind of pawn walking around and just being limited to the platform that they are at. It makes them feel very stupid if you jump off this ledge and then jump down here and the AI character can't reach you and runs the whole way back, and then you can essentially glitch out the AI, making it feel a little bit like you're robbing yourself from a proper experience, right? So we're going to be doing some nav links and finding out how they work and their limitations and what you can do to work around that. And to do this is very simple. We can go to create and we can go to not entirely sure where we can find this, but it doesn't matter. We can go to all classes and we can just type in nav, and then we'll get something called a nav link proxy, and this is what we're after. So we'll click this, and I accidentally managed to change to a plane before I released, so let's try that again. Nav link proxy, like so. So here we have a nav link proxy. We do not. We have a pawn. Let's try that a third time. Nav link proxy. Let's drag it out like so. This time it worked better. And what you see we have here is essentially a icon and two cylinders. Now, each of these cylinders represent a jump source or a destination, depending on which pathing you're going. If you're going from, you can see that it has a description next to it. It says point link right and point link left. So you can have a direction from right to left or left to right, for example. And depending on in which direction you're going, obviously the source and the destination is going to depend on that. If you're jumping from left, this is the source and this is the destination, and vice versa if you're going in the other direction. These 2 points, they are widgets, and you can see them here if you go to the details of the nav link. Under the category Simple Link here, you have something called point links, and it starts off with one array element in it. And you have a left category, which is the coordinate system for the position of this widget. So moving this around, you can see it gets changed. Now, by placing these two widgets, one perhaps somewhere over here and the other one somewhere down here, will create a link between these two positions. And these can sometimes be a little bit finicky. I usually find the best results when the cylinder is placed, although in Unreal Engine 4 you won't have cylinders, you'll just have these widgets in the middle, these, I don't know if they're 8-sided or either way. You place them sort of a little bit sunk into the ground and on top of what is considered a nav mesh according to the engine. It does have a snap radius, which should be helping out with finding a location close by that is an okay nav mesh to link to. Once you have these nav links placed, you also have the ability to decide in which directions it should be operating within. And you can also choose to have an area class if you want to give it a cost associated with it, so that the AI pawn can determine if this is the shortest or most convenient path to get wherever they want to go. But essentially this should be enough for us to actually have this working now. So let's test this out and see what happens. Actually, let's not do it in simulate mode, let's do it actually playing. So the character runs up to us and we expect it to follow us. So let's go up here on the top. So having stopped here now, jumping down here, it should hopefully follow us down along the edge. And you see that it does. Now that's all good and fine, and this is essentially what nav links are most easily and best used for. To allow you to jump from a higher location to a lower location just by simply moving off them. But if we wanted this character to do the same thing against us when it's on the low ground, you'll see that it won't work as well. Because having followed us here, it will now try to go to where the nav link is, because it says that there's a connection, a bridge between these two different places. But just moving there won't actually get it up here. It can't get to this elevation without any help. So this is where we can make use of something called a smart link. So a smart link comes along with a nav link immediately. And if you wanted to, you can also create your own classes for this. You can just go and create a blueprint class. And that's actually what we're going to be doing. So we'll type in nav link and you'll get a nav link proxy. We'll do it like so. We'll call this BP underscore nav link. Let's just call it NLP for nav link proxy tests, right? And then let's find this and we'll replace this with the selected actor. Let's see, it has replaced it over here right now, so that should be working fine. Let's just double check and make sure that it's actually working. Still, it seems to be working, good. Okay, so now we have our own proxy created, our navlink proxy, in which we can determine how this one should work. And one of the things we can do is we can make use of the smart link over here that you see in the details. Now, a smart link, what that does is it allows us to have some more advanced logic available to us when something happens. So if we open up this blueprint, like so, and we'll close out these other things, you can see if we go to the event graph here that let's see here. Here we have the smart link component over here, and in this event graph we can make use of a very usable event. This event is called something receive smart link. This one, event receive smart link reached. So this is the event that will trigger whenever an AI pawn reaches this smart link source, essentially. And you'll get the reference to the AI pawn, and you'll get a destination to the other link, so to speak. What we can do is we can start off with just doing a print saying smart link reached, like so, and then we run and we'll see what this character does. So we run to this area over here. Actually, we forgot something. If we go to this link proxy, we can go, first of all, we need to go to the smart link section and copy endpoints to make sure that we get the same coordinates for the smart link as the simple link so that they're matching up. You don't need to have them that if you want to have some other logic, of course, where the different points are in different places and such, but for our purposes here. And what we want to do is also we want to make sure that the smart link is relevant. And save all. And also on the class itself, we want to make sure that link is enabled on the smart link. Let's have this both ways, probably. So now if we go over here, we run to the AI, we make sure it's over here, jump up over here, and it chases us, and you can see that smart link reach has been typed over there in the text. So the event is triggering and he's realizing that it has reached a smart link area. So what we can do now is we could make this character jump up to this location, for example. Now we don't want to have the actual link itself determine that it should be jumping. So what we can do is we can create a interface. We can call this BPI for blueprint interface, and we can call this nav link reached. And we open that up and we make a function where we say nav link reachable, like so. Actually, let's rename it to nav link in reach, in range. In range is better. So, and what we want to do is we want to send an input. We want this to be an actor, like so. And we want to have another one which is going to be a vector. And we'll call the first one agent. And the second one, actually that one is quite unnecessary. Let's do nav link proxy destination. So let's remove the first input. We don't need that one because, well, it will become clear soon. So essentially this will be our interface where we communicate that this has been reached. So what we'll do is we'll send to this agent that nav link in range message, and we'll just plug in the destination. So this is why we don't need to have the input, because we're already sending it to the specific agent, right? The AI character that is involved, which in this case will be this character over here. So for this character, we want to implement this interface. So we go to class settings, and this is another interface from another tutorial, so we'll just ignore that, and we'll do a BP navlink reached, like so. And we'll make sure to implement navlink in range. So this is the event that will fire when we get in range then. And the reason we put this in the character is because it makes more sense that if we want to jump to a certain location, because we are in range of a navlink, we want the character to have the logic in there to decide that what it wants to do. We essentially just want to get this notification saying we have the ability to jump there if we want to, and then we decide here, do we want to, and if so, we jump. So we will be using a launch character function for this. And essentially we're just gonna make it have a sort of curved jump to get to the destination. Now you don't need to do it this way. You could have, for example, a character that teleports. You could have like this, a navlink being like a portal, so it teleports between different locations, or you could just have it walking off with a simple links, or you could have some other kind of way to determine what kind of a jump or trajectory that a character should have. It might be something like a spline or something like that to follow. Who knows how you want to implement it, but we're gonna be doing a launch character for this. So we will type in launch character, like so. And now we just need to calculate how to get this moving. So to have this done, we will be making a vector, and we will be overriding the X and Y, and we will also be overriding the Z, because regardless of what kind of a speed the character had before it reached this smart link, we want to say it should be determined by whatever we have calculated here. And to get this, we are going to get the destination. We're going to be breaking this into separate components. We also want to get our actor location, and we want to break that as well into components. To be able to make this somewhat flexible, we want to have a duration for this jump to exist. So we'll make a jump duration variable, and we'll make this a float, so we can say that it should take some amount of time. We can begin with maybe 1 second as a default. And now from here we're just going to be making some transitional mathematics, saying if it is in position X over, actually this is the beginning, this is the source, so the position X over here, we want to reach this X over here. How do we reach it? Well, if the duration is 1 second, then we want to have a force that is the destination minus the destination minus the start divided by the time it takes to get there, essentially. So we'll be creating a few math expressions to have this a little bit cleaner. And we can type in something like destination X minus start X divided by, and let's have parenthesis around that subtraction, and then we try to fix this, divided by jump duration, something like that. So since we have a variable for jump duration, this math expression is already going to be getting that here, and it's essentially just going to be performing this math expression for us now like this. So what we do is we take the destination X, which is this variable, and we take the start X over there, and this is now going to be our output vector over here. So now we can do the same thing for the Y. It's going to be destination Y minus start Y, and that's divided by jump duration. And we do the same thing here. We just plug in these values like so. And now we get to the Y, the height, the more complicated of these calculations. And you can choose whatever estimation you want to have here for yourself, of course. I'm just going to be using a formula. So we will be typing in, and this might be a bit difficult to follow, so I'll try to zoom in if you want to type this in like me. So we're going to have something like, let's start with a parenthesis, we'll likely need this. So destination, height, destination, that's not how it, destination height, excellent, minus 2 start parentheses, and then we have start height minus 2 parentheses power 1 parentheses jump duration comma 2, meaning we will have the power of 2 for this equation, 2 end parentheses and multiply by 0.5, and 2 end parentheses and multiply by gravity and divide by jump duration. That is not correct. Let's see. So we need to have all our parentheses end after gravity. That seems to be the right amount. So 1 star 2 3 4 5 6 1 2 3 4 5 6. Okay, so this seems right. Let's hope I managed to type it correct. So we're going to be taking our destination height, which is going to be this one, our source start height, which is our current actor location, and our gravity, which we can, for this instance, we could have typed in just whatever we wanted to have it, but let's promote it to a variable. Let's be good about this. We want it to be a float, and we want it to be, let's see, we want the gravity is 980 approximately, 981 in Unreal, I think, something like that. So we take jump duration power 2 multiplied by 0.5 and the gravity, and we have our destination height minus our start height minus that and divided by jump duration. And this we use as our launch character. Let's see if I got this at all right, or if this is just crazy wrong. So we walk over here to get him to go here, and then we jump up here, and now he should be going for the smart link, hopefully. And he didn't seem to be launched. And did we actually enable smart link? Let's do a print string here. Jump exclamation mark. Let's try that again. Okay, so we're getting to the jump. I have obviously typed something wrong. Let's see here. Okay, so having looked this over a little bit, I think I can see the issue. I think I've written the calculation incorrectly. If we remove the parentheses from start height, move it to before the power one, and we move one of these parentheses over here to gravity, I believe. Again, you need to keep check of what you're doing if you're doing math expressions, because if you do an error like I did, it can be easy to miss it. Let's change the jump duration to something small again. So 1 second. Let's see if this works better. So we walk over here. We jump up over here. And the character jumps up. So that works after trial and error. So essentially, now we could theoretically go and say we want to have a 2-second jump or something, and hopefully this should be working fine. Just jumping higher and taking a bit longer, but landing on the same place. So that seems like I managed to get the calculation correct in the end. Anyway, whatever way you want to go about doing this is largely irrelevant. It's a matter of how you want to handle it. You can look up equations of different trajectories and stuff like that if you want to have a jump working like that, or you can just have a different, simpler launching being done, or a teleport or anything like that. It's entirely up to you. Also, what you can see here now is that we managed to lose the gravity. We defined it as a variable, so at some point when we compiled it, it managed to identify that and it removed it as an input over here. So that's why that one was hanging loose. But yeah, I hope you were able to follow along and it made sense. This is essentially how you can make use of nav links, and there are of course a lot of depth and complexity you can bring about in this area if you want to, but this should be like the most broad and easy surface level of understanding how they work and how they can be used. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.